Now for the table of squares, let's try the square of 1.6. Now the square of 1.6. To find the square of 1.6 using a mathematical table, let's treat this 1.6 as 1.600. 1.600. Then let's locate the row labeled 1.6 in the mathematical table and look under the first column. The first column labeled 0. This will be our first column. The first column labeled 0. Now the value of the intersection will be our answer. The value of intersection from column X is 1.60 bring us 2.560. 2.560. Let's try another one. The square of 1.68. 1.68 squared. For this one, we'll locate the row 1.6. Locate the row 1.6 and move horizontally to the column labeled 8. Move horizontally to the column labeled 8. This will be our column. The column labeled 8. The value found at this intersection is 1.68. is 2.822. 2.822 to 2.822. 2.822. Now let's look at the third one. The third one. The square of 1.688. The square of 1.688. Now in this case, we'll follow 3 steps because we have 4 digits number. We had 2 digits, we had 3 digits, and now we have 4 digits. For the 4 digits, we'll follow 3 steps. And the step 1 is to find the base value. Find the base value, and we look at row 1.6, row 1.6, and column 8. The third digits are the column, so this would be our column. For 1.68, 1.68 we have 2.822. And now we look at the main difference section on the right under column 8. For this third digit, we look at the main difference. Mean difference section. Now for the mean difference section under 1.68, what we get? 1.68. We have 26. We get 26. So mean difference. The mean difference section where we have the large mean difference section. We have 26. Now, to get the final answer, we'll add the mean difference to the last digit of our base value. We'll add it to the last digits of our base value. That means that we'll add 2.822 plus this 26. We'll add it here. We are adding 26 here because this 26 is like is the same as 0.026. So just to save on time, to take this 26 to 0.026, we are adding it on the last digits of our value. So what will be our answer? 2 plus 6 is 8. And then 2 plus 2 is 4. Then here we have 8. Here we have 2. So the answer will be 2.848. That's the answer. Now that you know how to find the squares of your numbers using the mathematical table, let's look at basic examples. Basic examples. Example 1: 7.025 squared. 7.025 squared. Now our first step will be locating the value. Let's look for row 0.7 and column 2. So in this case, our column will be 2. This is our column, and then the final digit 5 would be our main difference. Yeah, our main diff. So now 7.02 in this squares table. 7.02 is on the next page, page 20. The next page. 7.02 give us 49.28. 49.28. So 7.02 gives us 49.28. 49.28. 49.28. And then let's go to the mean difference part. That part with the add. The mean difference part in the same row of 7.0. Let's look under column 5 in the mean difference. Column 5 in the mean difference section. Column 5 in the mean difference section. The same row of 7.0. 7.0 on column 5, we have 7. We have 7. And so we are going to add this 7. So let's write here our mean difference. Our mean difference is 7. Our mean difference is 7. So we are going to add our mean difference to the value that we got on the column. So how do we do it? We add 49.28 plus this. We place this 7 on the last digit of our value. Place it here because this 7 is the same as 0.07. It's the same as 0.07. So we add it here. And now when you add 8 plus 7 is 15, this is 5. Then we carry 1, 2 plus 1 is 3. Then we have 49.35. 49.35. That's the answer. 49.35. Let's look at the second example. Let's find the square of 9.713 using the mathematical tables. Now in this case, just locate the value. Let's look at the row 9.7 and column 1. Column 1. So in this case, this will be our column and this will be our mean difference. Now 9.71 is on the page 20. Squares 9.71 give us 94.28. 9.71 is giving us 94.28. 94.28. Now let's look at the mean difference. Then mean difference in the same row, that's row 9.7. Let's move to column 3 and look for the mean difference. 9.7, move to column 3. We have the mean difference is 6. The mean difference is 6. The mean difference is 6. Now let's start to find the final value. To find the answer, we'll add the value that we located plus the mean difference, and that will be 94.28 plus our mean difference 6. Always remember to place the mean difference at the last digits of values, because this mean difference is the same as 0.06. Yeah, this mean difference is the same as 0.06. So when you add here, 8 plus 6 is 14. Carry 1, that will be 2 plus 1 will be 3. So our answer will be 94.34. 94.34. Let's look at the third example. Let's find the square of 214.3. Let's find the square of 214.3. Now, this is quite strange because the mathematical table of squares can only give us squares from 1 to 9.9. You can only find squares from 1 to 9.9 directly from the mathematical table. So when you have anything that's more than 9.9 or less than 1, you have to convert it to standard form. We must convert it to standard form and then use the mathematical table as we have done with other numbers. So in this case, our first step would be to convert this 214.3 squared to standard form. So our first step will be to convert it to standard form. So to standard form, this point will move here 1 and here 2. So we'll have 2.143 times 10 squared. 2.143 times 10 squared. Now the number is in standard form. So to find the square of this number, we are going to square 2.143 times 10 squared. We are going to square it. Now this will be the same as 2.143 squared times 10 squared. I know by grade 8 you don't know much about the indices, but when you square 10 squared, you'll have 10 raised to 4. You'll have 10 raised to 4. Now, let's find the square of 2.143 and multiply it by 10 raised to 4. When you square 10 squared, just multiply the exponent by 2. We learned that in the indices. That's grade 9. But for now, when you square an exponent, you just multiply it by 2. So let's go to our tables. 2.143. In 2.143, the 4 will be our column. And the 3 will be our mean difference. So 2.14 gives us the table of squares. 2.14 gives us 4.580. 2.14 gives us 2.14 gives us 4.580. 4.580. The mean difference gives us in 2.14. Let's go to column 3. column 3. Column 3 is giving us 13. So let's add the mean difference to our value. That will be 4.580 plus 13. We'll have 3 here, we'll have 9 here, we have 5, we have 4.593. 4.593. Now we're going to multiply this 4.593 times 10 raised to 4. 10 raised to 4. And our answer will be 45,930. 45,930. So we just change to standard form and find the squares from the mathematical tables. Then we multiply by the power of 10 to find the answer. Let's go to another example, example 4. Example 4, let's find a square of a number that is less than 1. Example 4, let's find the square of 0.000412. Let's find the square of 0.000412. Remember that the mathematical table of squares, you can only find squares of 1 to 9.9 directly. For a number that is less than 1 or a number that is greater than 9.99, we must first write it into standard form. So let's start the standard form. The standard form, this point will move 1, 2, 3, 4. So we're going to have 4.12 times 10. Because it's less than 1, it will be negative. So that's the standard form. Now from here, let's square this one. This number is the same as this one, so let's square it. Let's square it. And then it's the same as squaring 4.12. Then when you square an exponent, you just multiply by 2. You learn more in grade 9 about indices, but for now, when you square an opponent, you just multiply by 2. So this negative 4 times 2 will be 10. Negative 4 times 2. So we'll have 4.12 squared times 10 with negative 8. And then let's go to our mathematical table of squares and look for the square of 4.12. That will be so direct. The square of 4.12 will be so direct. Column X, and then 4.1 will move horizontally to column 2. 4.12 is giving us 16.974. 4.12 squared is giving us 16.974. 4.12 16.974. 16.974. 0.974. So our answer will be multiplying 16.974 times 10 raised to negative 8. 10 raised to negative 8. So we can leave our answers in standard form. You can leave our answer in standard form. In the standard form, we'll shift this 0 to here, and when you shift the 0 to here, we'll have 1.6974. Then times, we shifted the 0 to the right. When you shift, not 0, the decimal, we shift the decimal to the right. And when we shift the decimal to the right, we are going to add that. We are going to add 1 to the powers. So negative 8 plus 1 will be negative 7. Negative 7. Yeah, we can leave the answer as 1.6974 times 10 raised to negative 7. Now let's look at the last example. Let's look at the last example of squares. Example 5. Let's find the square of 0.0357. Very easy, very easy. Now, this number is less than 1, so we can't find the square directly. We'll first transform it to standard form. Standard form. Now for standard form, we'll move the decimal 1, 2. So you move 2 places to the right here. Places to the right will be negative 2, 3.57 times 10. That's for 2 places, and because it's less than 1, we have a negative exponent. Now let's look at the. Now it was a square. So let's square this one. Let's square this one. So we have 3.57 squared times 10. When you square an exponent, we multiply by 2. This will be negative 2 times 2. Now we have 3.57 squared times 10 raised to negative 4. Now let's go to our tables and find 3.57 squared. That will be straightforward. The step of squares. 3.57 squared will be 3.5, then to the column 7. That will be 12.745. 3.57 squared will be 12.745. 12.745. Now 3.57 squared is 12.745, and then we multiply by 10 raised to negative 4. That is 12.745 times 10 raised to negative 4. What's the answer? Negative 4 will be moving to the right, so we'll have 2 more. We'll have 2 more decimal points. That will have 2 more zeros. So our answer will be 0.001275. 0.001275.